Hi everyone, welcome to Lessons Learned While Building the Friendly Dialogue System. My name is John and I'm from a Tasmania-based studio called Secret Lab. I work on a game called Night in the Woods, which shipped its iOS version very recently, so that's my plug. I also work on a tool called Yarn Spinner, which we'll hear quite a bit about over the course of the next little while, plus of course some internal projects. Of course, we all work on 1,000 internal projects. I also write books on programming and on game development, so I do a bit. This talk is really two things. It is a talk for individuals and small teams working on games tools, and it's also a pitch on open sourcing your tools. So whether you're doing something public facing or supporting others in your studio, I think there's going to be something here for you. So the context for this entire talk is a project that I work on called Yarn Spinner. Yarn Spinner is a dialogue system. It was originally written for use in Night in the Woods and is now used in many other games. The most recent title that I know launched with it is Lost in Random, which was published by EA, and you should go and check that out because some very cool people worked on that. Yarn Spinner is a bit different to other dialogue systems in some important ways. It's a complete programming language for dialogue. So as opposed to many other systems where you create nodes and each node contains a single line and you connect them together and that's how you form choices, we implemented a programming language designed for use by writers rather than primarily by programmers. The idea is that you write effectively a screenplay and you can sprinkle some logic into it. It's kind of a hybrid of nodes and scripting. Yarn Spinner, it was released under an open source license, and I'm going to talk in some detail about what that means and what that's meant for the project, and also what that might mean for you as a developer. So, with all that said, let's get started. Part 1, giving your code away for free. You may have heard of open source before. At this point, it's not a brand new concept, and even if you've only vaguely heard of it, you've certainly heard the phrase. Unfortunately, a lot of people have a bit of a misconception about what open source actually means. They think open source is when you go to GitHub and you download the zip full of the source code and you drop that into your project and away you go. And while that's not completely wrong, that's a big part of it. You do download the source code, often from GitHub. There's more to it than that. Open source means that you are developing your code using a model that is designed around public distribution of the source code and public contribution of changes back into that same source code. This allows for two things. If the source code is public, then two things can happen. User programmers can make the changes that they need to that source code to make it support the use case that they have. They can adapt that code to their own needs for their own game. But also, programmers are able to send those changes back upstream, as they say, to the project, allowing the project to get better. So that first point, programmers can make changes, means that the thing is adaptable, it's highly flexible. But thing two means that the project gets better over time because of its users. So why might you want to do this? And I'll come to why us in games tend not to be in the same kind of mindset as other non-game software developers when it comes to open source. There's really four main reasons why you might open source. One, you want help building a product that you can make some money off. This is a really common reason to open source. Most large open source based companies are based around this idea. For example, most commercial Linux distributions are based around the model of they make use of the open source software, they encourage its development, they support the developers who are working individually and contribute back, and then they sell a version of that to other companies. So that's one reason. Another reason, you want to build a product that draws attention to something else. This is probably the second biggest reason why people open source stuff. You build something so that people go and learn about you and they learn about the other things you do. Unity, for example, does this a lot. Reason three, you want help building a product that everybody would find useful. This thing should exist, and I want to make sure that as many people have an opportunity to help make it better as possible. So you see this a lot in independent and small teams where people are trying to build something good, and a way to make it good is to get as many eyes on the project as possible. And the fourth and most interesting reason to me, I think, is you want to create something that will outlast you. No programmer lives forever. No programmer retains interest in a project forever. So outlast you doesn't necessarily mean outlast you as an individual on this planet Earth. It also might mean when I'm sick and tired of working on this thing, I don't want the project to die. And open sourcing a thing allows for a degree of longevity that otherwise would be much harder to do if the source code wasn't available. All of these things are extremely valid reasons. Different open source projects have different motivations. Different people involved in writing open source software have different motivations. None of these are better or worse than the others. I don't want to make a value judgment saying that, oh, you're doing it for money. No. So I'd like to compare two similar and related projects in the field of games, in the field of open source, in the field of narrative. Yarn Spinner, my project, and Ink by Inkle Studios are two similar open source narrative scripting systems. Ink is by the well-known studio Inkle, who are famous. They made 80 Days, they made Heaven's Vault, they made Overboard. Yarn is by Secret Lab, my studio, which is much less well known. We're known for, well, we helped on Night in the Woods that one time. Ink is open source for two main reasons. The first is publicity. Ink is made by a company that produces games. The fact that they are able to be in the news and release new updates on their project while not having to release full entire games allows them to just get much better press coverage and much better attention than they might otherwise if they weren't doing this. Another interesting side effect is because they use a tool that other games can make use of, when those games themselves get press, there's frequently a mention of, oh, and it uses this cool plugin or library that Ink, who made 80 Days, use. So that's basically it's a way to generate a degree of interest that might otherwise not have happened. Another reason for open sourcing it is the tool had already existed for their own internal needs. Ink originally was not intended to be open source. They built it for their own purposes, and they released it as open source because there's really nothing to lose by giving it away for free. And that's a point I'll return to. By contrast, Yarn Spinner is open source for slightly different reasons. We wanted help when building this tool. We haven't really made this thing to attract publicity. We haven't really made this thing to make revenue, although that is beginning to change. The original motivation for open sourcing it was, I want to get as many people helping to build this as I can, and a way to do that is to open source it. And giving the thing away for free and making it open source is a great way to attract new users. These are slightly different reasons. Again, this is not better or worse, just different motivations for doing it. So our main objective was community contributions. We wanted to encourage two kinds of contributions: ideas for improvements and actual bug fixes and new features. And so far that's paid off. The games industry is notorious for closely guarding our secrets and our treasures like some kind of dragon. More game studios should open source their internal tools. I firmly believe this. Because we closely guard our stuff, we have all these different studios independently reinventing and redeveloping the same kinds of tools and solving the same problems everywhere. No one's sharing, at least nowhere near as much as they should be. Now, there's lots and lots and lots of open source projects on GitHub, but they're either side projects or they're spin-offs. There are some exceptions in the game space. For example, Godot is enormous and excellent, but most game studios make games, not software. The thing that we should be guarding and protecting is the games, not the tools that we make to make those games. We have nothing to lose and everything to gain by making it easier for others to contribute to common problems. Now, it's common for developers to call any source release open source. It's really straightforward to go, oh yes, well, the source code is available, you can read it, it's open, therefore open source. But that's not quite the entire thing. It's open source only if it's under an open license. An open source license allows a developer to both access the source code, that's the most critical part of it, you can read it, but also allows permission to modify the source code and to distribute their changes to that source code. The easiest way to ensure that other people are able to make use of your source code and make use of it in solving their problems, and also make it possible for them to send contributions back to you, improving your tool, is to use a source code license that's approved by the Open Source Initiative. So 3 are extremely popular: the MIT license, the BSD license, and the Apache license. These 3 licenses are referred to as permissive licenses, which means that, broadly speaking, you can do just about anything you like with them as long as you meet certain conditions, and those are very, very generous conditions. An excellent resource for this is the website choosealicense.com, and from there you can basically answer a few questions on exactly what it is you want people to be able to do with your source code, and they'll recommend a license for you, and it's all generally really straightforward. However, it isn't enough to simply toss code over the fence and say, done, I'm open source, time for the contributions to roll in, time for other people to start fixing my bugs. There's really 2 main serious considerations that you have to be aware of when you open source a project, and we encountered these when we open source Yarn Spinner. And that is the management of the support load that you incur when you create an open source project, as well as the additional elements of project management that occur when your users are also your fellow developers on the same tool. When you have more users, you have a higher support load. That's true whether you're open source or not. There's really 2 common approaches in the field of open source development. There's the community support route and the paid support route. These 2 are not incompatible with each other. Most projects do both. So when I say community support, I'm talking about telling people that they can go and go to the forums, go to the Discord, go to a Q&A site like Stack Overflow. That's where you'll go to answer questions or find help. We aren't available, we the developers are not available to answer questions. Maybe we'll be on the forums, but we don't guarantee it. If you want help, go and talk to your fellow users. Paid support, by contrast, is much more structured. It's more, you have an agreement with us, the developers. We will provide you with support for a fee, and we'll also make certain guarantees about our availability. And yeah, basically it allows you to have a bit more confidence at the cost of, well, the cost. Now, these 2 approaches can be combined. Like I said, most projects, in fact, begin with community support and then offer paid support when they have the infrastructure to do so. When charging for support, there's always going to be people who need specific support which you can charge for. I mentioned this is a really common approach in open source businesses. Most revenue in the field of open source software comes from support. Now, you should never ever withhold support on the individual level if someone needs it, if someone asks for it, because that's a great way to kill your popularity. But there is a difference between someone asking for help at the individual scale and a studio asking for help. The reason is that every time a studio or an organization or any other group adopts literally any tool, whether that is a small open source thing that you're working on in your own spare time, or a large entire project like Unity or Unreal that's fundamental to their games, they take on risk. Every time you bring on code that you didn't write, you take on risk. Primarily, I'm talking about the overall technical risk of what if this doesn't do the thing that we need, or what if it turns out that this kind of technique is hard. A well-run studio will know how to mitigate that risk. And in fact, one of the best ways that you can encourage studios to make use of the tool, the open source, is to charge for that support. It actually makes it more likely that they'll use the tool, not less. We have actually had several conversations with studios where they've approached us and they say, we're looking at using Yarn Spinner, but we can only use it if we know that we can get support. We say, well, we're happy to offer that. Now, paid support can mean a lot of different things. It can range from, on the small scale, simply guaranteeing that you'll be available to answer questions, through to prioritizing bugs that they file, all the way up to creating new features. Responding to questions is the easiest thing to conceptualize. If you're prioritizing bugs, that's not the same thing as guaranteeing that the bugs will get fixed. That's a very dangerous thing to offer. But even more dangerous to offer is creating new features, because the creation of a new feature also increases your support load for your non-paying users as well, people who are not offering you money for ongoing support. And increasing the complexity of your software is a great way to, as we know, make the whole thing kind of brittle and fragile. So that's support. What about project management? Well, when you make an open source project, as we found, you have two kinds of end users. You have the people who are just using your tool. They are the people who you designed it for. But you also develop a new kind of user, and they are your fellow developers. Because they have access to the source code, because they're making contributions, they're fixing bugs, they're adapting it to their needs, they're a certain kind of user now who is closer to the source code than an end user consumer might be. And you're accountable not just to your end users, but also to your fellow developers who may not be a member of your organization. They may not be part of your development team. And that means that the decision-making process for how we decide how certain features get built, whether we have a certain feature at all, that is no longer entirely up to the original people who built the thing. I originally wrote Yarn Spinner based off of only my own thoughts, but as the project gets bigger and bigger, it becomes more and more of a load to decide how we approach certain things. The whole thing becomes more complicated to run. You'll need to decide on who has the final decision-making authority on these technical decisions, and you'll need to publicize that. You need to say, final decisions are made by so-and-so. In the case of Yarn Spinner, that's primarily me. It's also my co-developer, particularly Tim Nugent. Because you're doing this in a community, the standard techniques and tools of community management apply both to your end users and to your fellow developers. You will need to create, publicize, and abide by a code of conduct. In the same way as you have rules for your Discord, you'll need to have a code of conduct for your project. They're necessary for the same reason as the rules of a Discord server are necessary. They give you, or the people that you deputize, specific authority that you can point to when something bad happens in your community. And the rule of the community is something untoward is going to happen at some point. It's a guaranteed thing. It's just a matter of time. And you need to have the tools to be able to respond to that. In other words, this is just the same thing as when you have a community of any kind, including like when you have players. So that's open source. I strongly recommend that more studios look into releasing their tools as an open source thing. It's tremendously beneficial both to your end users and to you. Now I'd like to talk about some of the lessons that we've learned when designing this thing as a product, because at the end of the day, Yarn Spinner is a product. You have way more non-experts than you have expert users. No matter how switched on your user base is, every one of them will not know something related to your project. They might be brand new users, they are new to your tool, they don't know how it should be used yet. But it might go bigger than that. They might be new to the field, they might be new to programming, they might be new to whatever it is your tool is for, art, music, sound design. They might be brand new. And this might be the first tool that Ed picked up. This means that your tools need to be as approachable as possible, even for internal stuff, internal to your studio that a very small team will use. Listen to your users. Look at the kinds of difficulties that they're coming up against. You are now a product designer. You are looking at the way that your product is being used. As well as looking at the things that your users are producing with your tool, we've also found that it's just as important to look at the kinds of things that your users don't produce because it's too hard to do it. You're going to hit those kinds of walls. People are going to hit the boundaries of what your tool allows them to produce, and you need to be able to recognize where those rough points are being hit. At the same time, though, you will also have expert users. Every tool has its unknown uses, the kinds of things that the developers never anticipated that the tool would be put to use for. It's very, very tempting to, as a tools designer, to say, no, that's not what that's for, that's not supported. You can try it, but I won't support you. But at the same time, though, that kind of new use can be a tremendous source of opportunity for you as a developer, because you don't yet know as you write what the hundreds or thousands or tens of thousands of end users are going to want to be able to do, or the ideas or the uses to which your tool would be put. Support users who want to do weird stuff with your tool. This is the same exact reason why people mod games. Design the tool so that it can be extended in some way. Doesn't mean make it a pluggable architecture or design it explicitly, but be open to new ways of it being used. It's really important to reinvent as many wheels as you need to, but no more than that. One of the things that we see a lot in games is not invented here syndrome, where you're reluctant to take on a technology because it wasn't developed by the team of people that you're used to working with. It wasn't done by you personally. Don't do that. Use someone else's code. Take on those dependencies. Move faster than that. It's really tempting to be seized by a really interesting problem, but that can be a dangerous time killer. The very first version of Yarn Spinner was done with a brand new, custom-made, hand-built parser that I wrote. And I did that because the problem was interesting to me, and I figured that it would make the most sense. I want to have flexibility. This was not invented here syndrome in action, because it caused all kinds of additional difficulties, additional problems. It made it harder to implement certain features until eventually we went, I just want to replace this whole thing with a parser library, which turned out to be an enormous benefit, and we've never looked back. We don't write our own parser. We also don't handle our own number pluralization. We originally wrote our own documentation hosting system because, again, I wanted that flexibility, or at least I thought that I did. And it turns out, no, what I dislike even less than lack of flexibility is having to maintain a system. So now we use Gitbook. You don't need to do it all. Find the one thing that your tool is really good at and don't try to implement the easy stuff that's already been solved by other people. Learn how to spot when your users are wrong. You're going to get feature requests. You're going to get people saying, can you make it so that it does this thing? Or can you change it so that it handles my workflow? And that'll happen no matter what scale you're operating at. Some of the time, these suggestions will be really good ones that you'll want to implement as soon as you can. Some of the time, there'll be things that sound nice but aren't really within reach, and you realize that. Some of the time, these will be things that users think they want, but they actually want something different. What they were reporting was a limitation and they offer a workaround. You don't want to have to hard code and commit to the workaround. It can sometimes be hard to tell the difference. And a default direction that I see a lot of projects take is, well, I don't know what my users are going to want to ask for in the future, therefore I'll make it adaptable. I'll make it flexible. And that's really dangerous. It's very tempting to make a tool that's very flexible. It makes sense because you're maximizing the number of people who might be able to use your tool. But the problem with a really flexible tool is you need to flex it for it to be useful at all. Credit to Oren Shaw for this phrase. To elaborate, when you design a thing that is flexible, what you are doing is you're punting on a lot of the design decisions that you as a tools author should have made yourself. You're saying, I don't want to have to decide this, you, the user, should decide this. This is the same thing that leads to enormously complicated settings panels in applications. The developer did not want to have to make that decision because potentially they were uncertain that they'd make the correct decision. Therefore, they punt it to the user. But that can lead to just, again, enormously overcomplicated projects and hard to maintain systems. You should be opinionated. You should make a decision and you should stick to it. That doesn't mean be bullheaded about it, but it does mean that you should not just punt on big process decisions to your users. Don't lose sight of the core appeal of the thing that you're building. To take us out, I wanted to just highlight a couple of smaller things that we found really, really useful in Yarn Spinner that potentially might be of help to you in your game or tool. The first one is one that I mentioned already, Antler. Antler is another tool for language recognition. Antler, it's a clunk, yeah, I know. If you need to parse some kind of structured text and get some kind of parse tree that you can inspect and navigate and make use of inside your code, then Antler is a tool for doing that. You write a grammar that describes the structure of the kinds of things you expect to see, and you feed that into Antler, and Antler gives you source code that you can then put into your game. It'll generate code in C# and C++ and JavaScript and many other languages as well, Swift, Java. It is fundamental to how we work in Yarn Spinner. It handles error correction, it handles error recovery, it handles tokenization and parsing. You can run a visit and walk the parse tree. It's just wonderful. Great for configuration files, great for simple languages. Another one that I think is really handy and is particularly of interest to any of us working in localization, which I hope is all of us, is CLDR, the Common Locale Data Repository. This is an enormous project run by the Unicode Consortium that basically they've gone through many different human languages and locales and codified the rules for how, among other things, numbers are pluralized, rules for grammatical gender, all of the stuff that's hard to do and also hard to know about if you are monolingual, such as like I am, like many of us are in the audience, I suspect. CLDR is fantastic for, in our case, we use it for, we pull the data on how numbers get pluralized and we use that to generate new source code that pluralizes numbers based on the player's current locale, which allows you to much more easily localize your lines. And that leads me to code generation. Code generation is a technique that I think is kind of much maligned because it feels kind of, for some reason, kind of icky to some people. But I want to say it's good, actually. Code generation is fantastic. If you need to dynamically generate some kind of logic at design time, at build time, then generate the code for that and stick that into your build pipeline. It is going to be much easier to do than building some kind of dynamic system that runs on the user's device. It's going to save you so much time. Yes, you are generating potentially ugly code that now lives inside your code repo. That's fine. It's nowhere near as big of a problem as you might be thinking. Humans are not expected to maintain generated code. It's fine if it's ugly. It's also quite a good idea to use this kind of approach for storing data. Why would you want to write out a configuration file that you know will never ever need to change when you could write out the same thing as source code? Your compiler is already a quite good parser. You can then dump out all of that information as a list or a table or whatever it is you need and have that be read in at compile time rather than at runtime. It can save you performance, it can save you time, and it also saves you having to write your own import systems as well. Finally, much more generally, I'd like you to remember that you should be designing with failure in mind. I write a programming language. You're going to make typos, you're going to cause the parser to fail. Failure is really common, and because failure in the context of tools is really common, failure should be supported and it should be explainable. Your users will make mistakes almost all the time, especially at the start of their use with the tool, when they're newbies, when they're novices and they don't yet know how it works. Useful error messages in any tool is the most important thing you can do, the most important feedback that you can offer. So ideally, you should be designing your tools so that errors are actually impossible to represent in the first place. But if that's not possible, then give an over-explained version of the error. A great example of this is the errors issued by the programming language Elm, which they basically sat down and went, the main reason why people bounce off programming in general is they hit syntax errors and they don't understand why, and the syntax errors are hard to explain. And so their solution was they made their syntax errors explanations on how to fix those errors. And that's astonishing. And I want more people like us to copy that approach. Thank you all very much for being a part of this and attending my talk. You can find more information on Yarnspinner at this address. You can also join our Discord at this address. And also please follow us on Twitter, both the project itself and also our studio and me personally, just for the ego boost. If you'd like some further reading, or rather further viewing on the open source process and how you might want to use that in your game development process, I gave a talk at GDC in 2017 about this, and I go into more detail about how to get a good outcome from open sourcing. So you can find that here as well. With that said, thank you very much.